Hey, it's me again. So something happened with the other video, and I wasn't able to proceed from this point onwards. So here's the rest of the video. So we've seen how to add and subtract vectors. Now we'll talk about vector multiplication, multiplying vectors. When I'm multiplying two vectors, this is called the dot product of vectors. And I think you spent a long time wondering why a lot of the times in mathematics, instead of doing 2 times 3, it's instead written as 2 dot 3 or maybe a dot b dot c, which means multiplication. So this dot product simply comes out of this field of vectors. The dot product gives us a scalar quantity, a scalar value, or a scalar result. And that's why we can comfortably use it when multiplying scalar numbers like 2 times 3 times x, because we assume them to be scalar values. So when we're doing the dot product of vectors, we simply multiply the x or I components and the j components. So we multiply the I components, which will be a1 times a2, and the j components, which will be b1 times b2. And that will be the result of v dot w. It's read v dot w because it's the dot product of the vector. Like I said earlier, this dot product will be a scalar quantity or just a number like 4 or 10 or whatever. That simply means that that's the result when these vectors multiply each other. Now there's two different things in vector multiplication. One is called the dot product and another one is called the cross product. The cross product is a little bit more interesting, but the dot product happens when those vectors are at 90 degrees to each other, and that's how these components are able to cross each other out. That's why you're able to get a scalar, because they're 90 degrees to each other. We might not go deep into this, but eventually when you study some more math, you'll find that that is how the dot product works. Is it going to give a vector as an answer? We've just been talking about this. No, it gives a real number, and that number is also known as the scalar product of two vectors. Example is here. Find v dot w. So v dot w, very big V, but v dot w will be, remember, multiply the I components, so 3 times -4, plus the product of the j components, which is 2 times 7, which gives you -12 plus 14, which is +2. That is the dot product of v and w. Is the dot product commutative? Yes, because if I have 2 times 3, that's the same thing as 3 times 2. So the vector product is commutative. Is it distributive? Yes, and I explained this earlier. If this goes into that and goes into that, the result I get is the same as if I did the product separately and added them. So think of it as if this is 2 and this is 3 and this is 4, you can decide to distribute, which will be 6 plus 8, which gives you 14, or you can decide to multiply after adding the insides, which still gives you 14. So it's both associative and distributive. The dot product of a vector with itself is equal to the magnitude of that vector squared. Because if you imagine, if I have a vector that is 3i plus 2j, right, then its dot product, I'm multiplying this vector 3i plus 2j by itself. I need to stop using multiply, because that technically means cross product. But the dot product will be 3i plus 2j dot 3i plus 2j again. So I'll multiply the x components or the I components, which will be 3 squared, and the j components, which will be 2 squared, right? I have 3 squared and 2 squared. And what you notice is this 3 squared and 2 squared, if it had a square root, would be the magnitude of the vector. But since it doesn't have a square root, it's the magnitude of that vector squared, if that makes sense. So this the dot product of a vector with itself is simply equal to the magnitude of that vector squared. Simply that. The dot product of a vector with 0 or with a 0 vector is equal to 0. And yeah, so we can use our knowledge of the dot product to find the angle between two vectors. So imagine you have these two vectors, u and v. They have that angle theta, which we don't know. I can use the cosine law to figure out what this angle is, what the angle theta is. I can use the cosine law to figure it out. From the cosine law, v minus u squared, that side squared, imagine this was side A. Imagine this was side A and this is side B and that is side C. But each of these sides, since they are numerical values, this is representing the magnitude of u, the magnitude of v, and the magnitude of u minus v, or v minus u. So the cosine law would say a squared equals b squared plus c squared minus 2bc cosine a, because this is angle A. So just plugging in with the vectors and magnitudes that I have, v minus u squared will equal to b squared, but b is the magnitude of v, right? Plus c squared, c is the magnitude of u squared, minus 2 times b times c. So that's now a dot product. It's not a magnitude product. That's going to be 2 times v dot u cosine of theta. When I expand, sorry, these are magnitudes. These are magnitudes. Magnitudes. Okay. So when I expand this v minus u squared, I'll have magnitude of v squared minus 2 magnitude of v dot u squared. Sorry, not squared. Just 2 magnitude of v dot u, because it will be 2vu. I'm using the identity a minus b squared is equal to a squared minus 2ab plus b squared. That's what I'm using. So this is going to be plus magnitude of u squared. All of that is equal to magnitude v squared, magnitude u squared, minus 2 magnitude v magnitude u cosine theta. I can begin to cross out some things. I can see on the left I have magnitude v squared, that cancels out with magnitude v squared on the right. I have magnitude u squared, crosses out with magnitude u squared on the right. And I'm left with negative 2 magnitude of v dot u. This is now a dot product because it's a dot product because I am multiplying these vectors. Is equal to negative 2 magnitude v magnitude u cosine of theta. So the negative 2's cancel out. Negative 2 cancel out. And on the left, I have left v, the dot product of v and u. And remember, the magnitude of the dot product is simply just a scalar value, because in this example that we did earlier, when was the example? We did an example. Did we not? Anyways, if we had found, I remember doing an example, right? Yeah, there we go. The magnitude of a dot product, I'm just trying to show you that the magnitude of a dot product is simply the same thing as the dot product. So the magnitude of this is simply the same thing as 2. So I will have v dot u is equal to magnitude of v on this side, magnitude of u cosine theta. And if I make cosine theta the subject, cosine theta will equal to v, this is magnitude, v dot u divided by magnitude of u, magnitude of v cosine theta. And that is the origins of the formula for finding the dot product, the angle between two vectors. If I want to find the angle between two vectors, I simply get the dot product of those vectors, divide that by the product of their magnitudes. So magnitude of v, magnitude of u, and on top is the dot product. You don't need to know any of this stuff that I did here, it's just for fun. So yeah, that's how you get the angle between two vectors. This is the formula. Cosine theta is the dot product divided by the product of the magnitudes. Example is here. If I want to find the angle between V and U, first I need to find magnitudes of V and U. Magnitude of V will be 3 squared plus 2 squared under square root, which is the same thing as 9 plus 4, which is the same thing as 13 square root. Magnitude of U will be negative 4 squared plus 7 squared under square root, which is 16 plus 49 under square root, which 16 plus 49 is 55 square root. So cosine of theta is equal to the dot product. I can find the dot product by multiplying the I components. Let me first find the dot product. So the dot product of V dot U will equal the I components multiplied, so 3 times negative 4, plus the J components multiplied, which is 2 times 7, and this gives me positive 2. So my angle cosine theta will equal 2 divided by the product of the magnitudes. The product of the magnitudes is root 13 times root 55. So finally, angle theta will be the cosine inverse of all of that, root 13 times 55. And you can just plug that into a calculator to find your magnitudes. To find your angle. Find your angle between the vectors. So I have inverse cosine 2 divided by square root 13 times 55, which is 85.7 85.7 degrees. Alright, yeah, so you can even sketch the vectors if you want, because this is 3i and 2j, 1, 2, 3i and 2j. That vector is going up there like that. And then the other vector is negative 4i and 7j, so 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7 over there. And I hope you can see that this angle is right around 85.7 degrees. Not around, just exactly 85.7. Okay, so this is your homework. Have fun.